I've turned 55 bowls, but I've never turned a segmented bowl, and it was time to start. It just always seemed like too much of a bother to cut all the segments. But wait a minute, I've got a CNC. It can do it for me. I've never seen anyone use a CNC to cut the segments, but I couldn't figure out why not. I was building a dining room table. It had 32 segments, was about 30 inches tall, and 32 inches diameter. If I could do that, I figured I could make a bowl. Most segmented bowl makers use a segment calculator. Then they use a table saw sled to cut all the segments. It looks like a whole lot of work to get everything the right angle. My CNC, it has no problem with angles, so I'm going to use it. So I had an aha moment. I could use radiuses instead of all the angled parts. I won't have to fight all the corners when I turn my parts. And it makes the math so much simpler. So what I did is I sketched the bowl that I wanted. So you can see something that looks like this. And I wanted the hub, this piece here. And this is only half. This is the center line of the bowl. So there's half of it over here, but this is just the half. And this is full scale. And you draw the graph paper, okay? So each one of these is 3/4 of an inch, okay? So that's my wood. So now, what I did is I went another quarter. Never having done this before. And a quarter on the outside. You've got your 3/4. It's trying to explain this. So you have the 1/4 inch outside. Here's the shape of the bowl, here's the extra quarter. When the quarter crosses this board line, you draw a line. That's the outside radius of your segment. So here's the next one. It's down here. As this one comes up here, it's there, and there, and there. So now you go to the inside, where this is here, draw that line, okay, where it's at the bottom, okay, it comes up. So here, the inside 1/4 inch extra quarter, you go there. Here, it crosses there, so you go straight up. And you come here, straight up, and straight up. So now you can see your segments. There's the top one. Here's the next one. The third. The fourth. And the last one, plus the hub. So that's how you figure out, here's your extra quarter. So then you go up. On the other side, you go down. So up and down. And that's how you figure out each of your segments. Then you just measure from the center line over, the center line to the outside. And that's how you know how big each segment is. For the CAD, all I needed was the ID and the OD, and I had the rings. Then I had to decide how many segments I want per 360 degrees. That is simple math. I then reduced it to each segment so I could put it into my CAM system. A quick check of my stack up, and things look pretty good. I made a decision to use a central hub. It would have 3/8 protruding into the rings, and it would have 3/8 sticking out for me to chuck up on. I thought this was a good idea, but I've never made a segmented bowl. I used the CAD system to get all my 2D parts ready to go into the Carveco CAM software so I can program my CNC. I brought the segments into the Carveco software and then worked very hard to get them as close as possible so I could get as many parts out of the 1x6 board that I bought. When I run the simulation, you can see that there's hardly any wood left in between the segments. My CNC will do 4 foot by 4 foot, but I chose to make these boards 3 feet long. Tried to pay attention to the grain orientation. To hold the parts down, I was going to use the blue tape double-face tape method. The high-density pack, there was no room for tabs. I thought this was the way to go. I tried to do a very good job of getting the blue tape on the board and then on the base, waste board. Watch how I put down the glue. We'll be talking about that in a minute. I always add buckets to let the glue cure, even though it's very fast. Well, here we go. Let's start cutting our segments. Uh-oh, did you hear that? The first segment released off the blue tape. You can watch it move. Uh-oh, the third segment moved, but the fourth segment didn't. Turns out I did a very poor job of putting the glue between the blue tape, and that's what caused the failures. As we run through the rest at high speed, you can see which ones released and which ones didn't. I need to improve my blue tape gluing method. Okay, so now for the second board. I'm going to use the same thin CA glue, but I'm going to put it on a lot thicker so that we have a lot more coverage. This should help hold down all the small parts. Here we go again. Let's see what happens. Everything appears to be sticking pretty good. Haven't had any parts release. These parts are a little bigger, so that helps too. Oops, there went one, so I lost one for the whole board. But if we look, it's right over the T-track, so I have to be careful where I put parts, because there's nothing to hold down the blue tape over the T-track gap. All in all, that worked much better. So all in all, I had 13 parts move, or didn't cut properly. So I'm going to recut those, but this time I'm going to use tabs or bridges and the blue tape. Here you can see what the tabs look like in my Carveco software. Note that I put the tabs on the inside and outside of the bowl rings, not on the faces that get glued together. This shows the comparison of using the tabs. You get much lower density. You don't get as many parts on the board, on the white with the tabs, as you do in the yellow with just the tape. That's why I wanted to perfect the tape. This time I'm going to use the thick CA glue because it's set slower and I'll have time to get better coverage and see how thick it is. I'm going to use a piece of tape folded over on itself as a spreader because it's going to be trash. That is much better coverage without any holes in the glue. Here I was moving the board just to help spread the glue and I could feel it grab. Here we go. We shouldn't have any problems, and I probably didn't need the tabs getting the glue this good. Probably the best solution is just to use real double-faced tape. You can see that worked perfectly. And it's really stuck down to the waste board. Now you can see the tabs or the bridges. That worked much better. And if I spent as much time on the glue on the first two boards, I may not have had a problem. This is my first segmented bowl, and I thought it'd be a good idea to put a hub or a chucking point on the bottom, so I'm going to turn it before the glue up. Wanted to sand the ends of the segments, so I used my belt sander, but I didn't turn it on because that would have been too much. Now for the segment glue up. I used wax paper to keep it from sticking to the bench. This is a great trick if you don't know it. I used a silicone brush to cover both ends to make sure I had good coverage, and I used hose clamps to pull them all together. This went very well for my first time. Everything looks pretty good, so I'm taking the band clamps off 24 hours later. Now I mark the center of each segment so I can do a brick-laid bowl and alternate the rings. Now I mark the inset for each ring as we climb up the stack. Now it's time for the glue. I chose to only do 3 rings the first time because things started to slide and it was easier for me to manage. I should have planned my clamping strategy a little ahead of time, but it worked. The first 3 rings glued well, so now let's do the rest. So let's unclamp the final stack. Well, that looks pretty good to me. So let's chuck this up and get turning. I decided to use a live center with a flat face so I didn't mar the surface. This will be good in case my segmented bowl flies apart, and it'll hold a little bit. Now for the fun, let's start turning. I'm using a 1/2-inch bowl gouge. I'll start on the face and then the outside ring. I'll then work my way down the bowls, smoothing all the segments. This is nice. I'm not used to turning kiln-dried, dry wood. With a sharp tool, it cuts like butter. My bottom ring is end grain, and the rest are side grain, and you can see how it turns differently. Now to use a scraper to smooth things out. I like the side grain shavings better. I'll have to change my next segmented bowl design. Now to turn the inside. I have a confession to make. I like bowls turned thin. Started out with a straight tool rest, but this curved bowl tool rest fits perfect. I switched to a scraper trying to get a better surface on the bottom. Uh-oh, we got a problem. You can see a thin spot where the light's coming through in that bottom corner. That's not a good thing. So I've made 2 big mistakes. The first is, on my segments, I probably didn't leave enough overlap in that corner, so I've turned it too thin. The second mistake is I went back out to the edge, and you see the thin bowl is bouncing and causing all kinds of gouging on the last outside ring. I have to think about what I'm going to do. You can see it's so thin in that area, you can see the shadow of my hand on the back side. Can we rescue this bowl? Outside edge, you see all this gouging. If I would do what I say and not what I did, I wouldn't have touched it. Normally, when I turn the outside third, I never go back and touch it again, because it's well supported before you do the second and third depth pieces. If I cut the outside ring off, this bowl wouldn't look too bad. The bottom of the bowl, the surface finish looks like crap. I think I can smooth it out, but I can't dig into the corner where it's thin. My center hub I thought was a good idea, but the fit-up problems are just too much. I shouldn't have done that, and I won't do it again. So let's chuck it up and see if we blow it up or repair it. We'll start on the bottom using a scraper. I have to be careful again in the corner. If I can fix it, it won't be a perfect bowl, but I'm too stubborn to quit. There, that doesn't look too bad. Now we move to the outside to cut off the top ring. Start with a parting tool. But I think that's putting too much pressure on, and I don't want to blow apart the bowl. So I switched to a skew. The skew's knife edge is putting a very little load on the bowl. I'm going to turn it over, and I think I'll get a much better cut. That's better. And now, everyone's favorite, sanding. I'm power sanding with my drill. I used 80 grit on the bottom to clean things up, then went to 120 and 220, inside and out. This doesn't look too bad for a rescued bowl. So this is a junk bowl, so I reached in a drawer and grabbed some solid carnauba turning wax made by Hutt. I wasn't thinking. It's a friction finish, and you have to turn the bowl up to high speed to get a really good finish. And I don't want to do that because I got that thin section. Oh well, another mistake made by me not thinking. Do the best I can with it. I'll use paste wax on the outside, so I'll add a little bit of paste wax on the inside too. What more damage can I do? For a rescue junk bowl, this doesn't look too bad. Not my finest work, but I learned a lot, and the next one will be better. So let's look at all my lessons in humility. First, the bottom segments I would have turned 90 degrees. Then I wouldn't have been turning end grain, and I think it would have been better. Next, I didn't mention it, but after I glued up the segments into rings, I forgot to sand them. Just got excited and in a hurry. I don't think I would do the very bottom ring the same way again. It's very hard to get all the segments to match up into the center, and I had some small gaps, which I didn't like. The thinned area was a design flaw. I should have had a larger segment overlap. As I mentioned earlier, I had a whole bunch of chatter and gouging on the outside ring, and I shouldn't have revisited after I did the initial turning. For my next segmented bowl, I'll use double face tape. That way I should get a better hold down, and shouldn't screw up as many parts. I'll pay attention to the T-track location and small parts. And I shouldn't have used a friction finish on a bowl I didn't want to turn at high speed. Lessons in humility. But this was a lot of fun, and I'm going to make another segmented bowl. Thank you for watching. Please subscribe, like, and ring the bell. I appreciate you watching the Johnsonville Woodworker.